Hi everyone, this short video is going to introduce the concept of a derivative of a function. So I have a parabola here, that's this lovely green function. I probably should have typed the equation for that function, but that's not really the important bit here. The important thing about this is I want to find the rate at which the function is changing. So at the moment I have a point here A, and that's the point that I'm really interested in. I want to know how quickly the function is changing at this point. And as we know from our previous work, a rate of change could be, an average rate of change could be found between taking a straight line gradient between 2 points A and B. And this point B over here is another point on the function. At the moment, it seems that point B is 4 units to the right of point A, and it looks to be a little less than 60 units higher. And just slide that across a little bit, except it doesn't want to slide for some reason. That's better. Slide that across a bit, and close enough. So the difference here, the vertical difference is 60, the horizontal difference is 4, so the average rate of change, or the gradient of that secant line, is about 60 divided by 4, roughly 15. And there it is. Now we've denoted this here as this is our point value of x, and this is a distance of h further on, so that's a value of x plus h. Perhaps I should label those. So this point here would be a coordinate of x, and then the y value would be whatever the function of x is at that point. So that point A has an x coordinate of x, and the y value is whatever the the function's value. Over here at this point we've moved a distance of h, but the function is no longer, that point isn't on the function, the point on the function is all the way up here. So we'd better have a label up there that point is a value of x plus h to the right, and the y value, or the value of the function, just substitute x plus h. That's the coordinate of our point up here. So you can see where this formula comes from. The gradient of that secant line is the y value of this point, f of x plus h, subtract the y value of this point, f of x, and if we subtract this x value and subtract this one, so x plus h, take away x, we're left with the distance of h across there. That's why it's divided by h. And as we thought, about 60 divided by 4 comes to 15. Now, that's a very rough approximation for the rate of change of the green parabola function here at this point of interest, which is point A. I could do a much better job if I bring this closer. So if point B is sitting here, then, for some reason my label didn't move, that's a bit annoying. So now I've got a difference, a vertical difference of 40, a horizontal difference of 3. 40 divided by 3, it's about 13. Well, that's not exactly on 40, this is a bit rough. So there's my gradient of the secant, it's 13. It's less than it was. I could do even better if I brought that closer. So I seem to be about a bit over 20, and that's a difference, that's 2, so I'm down to 11. You can see that the secant line, the black line, is getting closer, and the gap between this and the actual function is getting less and less. As this point comes closer and closer and closer, my secant line is getting more and more like a tangent. It's not exactly a tangent. If I zoomed right in, there'd still be a gap between point A and B. And my gradient is now right down to about 7.4. If I get even closer, come on point B, even closer, oh, too far. So what happens if point B lands on top of point A? I get an undefined. Why is it undefined? Well, because I'm dividing by 0. The difference, the horizontal difference h between point A and B is nothing. That mathematically doesn't make sense. That's why it can't give an answer. But it did seem when I was getting really close that I'm getting very close to the value of 7. What happens if point B starts coming in from the other side? If point B starts coming in from the other side, here's my gradient, about 3.3. The secant is up to 5, 5.7, 6. And again, as I'm getting closer and closer, approaching from the left, I'm getting closer and closer to 7. Of course, I can't actually have the 2 points on top of each other. I cannot calculate. So this is where we need the concept mathematically of a limit. As point B approaches from the right, the value of the gradient of this secant is decreasing, seeming to approach 7. And as we approach from the left, the value of the secant, the gradient of the secant, is increasing, and again seems to be approaching 7. That's the concept behind derivatives. Next video is going to show you the details of the algebra involved.